So a quick introduction to this is we're going to use a formal proof, a two-column proof, okay? And what we're going to do is in one column, we're going to put statements, and in the other column, we're going to put reasons. Now, what kind of things do we write down in those statements? Well, we're going to put facts that we find out about a problem. Facts from a problem. Or they could be facts that we discovered during the middle of the problem. Now, how do we know they're facts? Well, a lot of times we know they're facts, and that's because of the reasons that they came from to begin with. The reason that they might be facts are because they might have been given to us. At the very beginning of the problem, I might have given you something and said, this is a fact. And then you always have other reasons like definitions and properties. Some things called theorems and postulates, and we didn't spend a lot of time on the particulars of those words, but you've seen those words before. You know that we've talked about the angle addition postulate. I keep using the word postulate. You know the word theorem from Pythagorean theorem, right? Properties. There's a lot of properties that you know. Probably the one you use the most often in algebra, the distributive property. But there's a lot of other properties too, symmetric property, identity property, addition property. There's lots and lots of properties. And then of course you've got definitions. How do you know what something is? Well, everything's got a definition. Okay? So these are all different reasons and things that can come up. You've seen this in the past. Before I go into the formal part of this, I want to just read through my problem, mark my picture up, and decide what things I know are true and if in fact I can prove that C is congruent to Q. Angle C is congruent to angle Q. So the first piece of given information is angle CAB is congruent to QPR. So I'm going to trace that. That's CAB and QPR. I know those are congruent, so I'm going to immediately mark those in my picture. So I used this information, didn't I? Okay, that was given to me. Let's see, what else do they give me? They give me this about AB and BC being perpendicular. Well, what does perpendicular mean? Okay, it means they make a right angle. So right here, I have a right angle because of this statement. And because of the one right beside it, I have two right angles because of these statements. And I got one other piece of information given to me. What's that? Side AB, and I trace that. I always trace things when I read it. So side AB is congruent to PR. Well, that's this guy and this guy. So just take a step back and think for a second. Can you show me that C and Q are equal? All right. I know that C is equal to Q because I know that this first triangle is equal to the second triangle. How do you know the two triangles are congruent? Okay, so I know angle side angle is going to give me two congruent triangles. And then once I have congruent triangles, how do you know that C is congruent to Q? Oh, we probably don't remember this one. It's an acronym, that's right. Remember, it's CP. CTC, and it stands for corresponding parts of congruent triangles are congruent. But this CT right here, congruent triangles, before I can talk about corresponding parts being congruent, I have to show congruent triangles. So this comes first, and then that comes second. All right, I think I got a plan. Let's make it work. I can talk about what they gave me, which was angle CAB is congruent to angle QPR. And that was given to me. So the reason I know is because it was given. I think it makes sense, since I'm trying to do ASA, angle, side, angle, it makes sense to give an angle first and then a side and then another angle. So I'll try to talk about the side. The side was AB and PR. Well, how did I know those two were congruent? It was also given to me, all right. So AB is congruent to PR, and it was also given to me. So even though I'm a couple steps away, this perpendicular came from the given information. So I'm going to write that down. And yes, you do have to write it all down. So that's AB. But I could combine them together, and I think I will. So in order to clearly show that I have two angles that are congruent, I know these are perpendicular. What does perpendicular mean? It means they're right angles. So I now know that angle B and angle R are right angles.
Why don't you just say they're congruent?
Okay, that's a good question. The reason I didn't say they were congruent yet is because all they told me was that they were perpendicular. And what's the definition of perpendicular? That they're right angles. So this is actually the definition of perpendicular. And now once I know that they're perpendicular, once I know they're right angles, do I know that they're equal to each other? Sure, how do you know that two right angles are equal to each other? Yeah, they're both 90. All right angles are equal to each other, aren't they? So there's different ways I can write this down at this point, but I think I'm actually ready to write it more clearly here. I can say, I could say that those two angles are equal to each other, or I could say angle B equals angle R. And if you wanted to, you could even say equals 90 because of the right angles, right? So now you just told me the definition of a right angle. So now that I am prepared to talk about my two triangles being congruent, I can say 6. I'm totally running out of room. I'm sorry about that. But now I can clearly say that triangle ABC is congruent to triangle, match up ABC. It's going to be PQR. It's got to be PQR in that order, right? And what's the reason there?
PRQ.
Oh, it would be, yes. PRQ. And what's the reason? It'd be angle, side, angle. Angle, side, angle. And then that leaves me with one last thing to write, and I apologize for the spacing. But was I able to show angle C congruent to angle Q? I was. And the reason for that is CPC-TC. So I'll give you a second to get caught up. So I'm looking over here, and I'm trying to make a plan of attack. You're thinking it's side, side, side. I had two sides were given. And what would be my third side? Okay, the one that matches on the inside, right? The reflexive one. All right. So I think I have a plan. Now I just need to execute this plan over here in a nice organized fashion. All right, so I'm going to start off with statement number 1. Give me something. Yeah, PQ is congruent to PS. How do I know that? It was given to me. Is that one of my sides? Yes. What about another statement? QR is congruent to SR. How do you know that? It was also given. Now, some people do like to combine those together. I don't, because to me, they're giving you two different pieces of information. Step number 3. PR is congruent to what?
RP.
Well,
PR.
Well, it's equal to.
look up here and look at the order that they want it. PR, PR. It's actually going to be equal to itself, isn't it? So PR is equal to PR because they're the same. That's exactly right. That's called the reflexive property. And I'll go to the board and show you the difference on those. Reflexive property. Have I clearly established 3 sides? So as long as I have clearly established all 3 sides, I'm ready to make my final statement, and that is triangle PQR,
How do you spell reflexive?
triangle PSR, and the reason would be side, side, side. So like I said, we're done with this problem, but there's 3 properties you need to know. If you've got something that looks like this, all right, that's the identity, okay? But if you have something that looks like this, you're going to call that reflexive. Not a big difference, right? Not a big difference at all. But here's the big one. If you have AB equal to BA, that's called symmetric. Okay? Normally up here with the AA, it's normally not even A's, it's normally numbers like 5 equals 5. But when you start getting into these situations, basically think about it this way. If you're equal to yourself, bless you, that's reflexive. You look in the mirror, who do you see? Yourself. If you're equal to yourself, it's reflexive. If you can draw a line of symmetry, then it's symmetric. Do you see how those are kind of symmetric like?
Yeah.
So that's the difference between those.